Hi everyone, for today's lesson we are going to learn how to evaluate logarithms using our graphing calculator. So for today's lesson you will need a calculator that has a log or an LN button. As long as you have a calculator that has one of those buttons, you will be okay for today's lesson. So if you need to pause the video to make sure that you have a calculator to work with, that might be a good thing for you, just so that you can practice using a calculator for today. You will be allowed to use any type of calculator on your test coming up later on next week. So before we get started, what I would like you guys to please do is I would like you to please go ahead and factor the following. So we have 4 problems that I would like you to factor. The first one is x squared plus 25. The second one is negative 3x to the 6th power plus 81x to the 3rd power. For number 3, we have 4x squared plus 43x plus 30. And then finally, we have 25x squared minus 49y squared. So it's kind of tough to read, but that is supposed to be a y squared. Please pause the video and factor each of these expressions on your own. And when you have an answer, please restart the video and we'll see how well you did. All right, for the first one, hopefully you were able to see that the first one is not factorable. It's not factorable at all. This is the only type of not factorable problem that I will give you throughout the year. So very few problems that you'll see on your test will be not factorable. And typically the not factorable ones will be what we call a sum of squares. This is a sum of squares. You cannot break it apart into x plus 5 and x plus 5. And the reason why is that if you were to multiply x plus 5 times x plus 5, you would end up with a center term. And in this case, this is an SOS, a sum of squares. And if it's an SOS, you cannot factor it. For number 2, both of these two terms have in common a 3, and they have at least 3 x's. And because we always want our leading term to be positive, I'm going to factor out a negative 3x cubed. And what I'm left with is an x to the 3rd power minus 27. Now, x cubed minus 27, that is a difference of cubes. So that means that we're going to break it apart using SOPs. So I'm going to still have the negative 3x to the 3rd power on the outside. It's a part of our problem. We ignore it, but we don't forget it. It needs to be a part of our final answer. Then I'm going to take the cube root of each term. The cube root of x cubed is x, and the cube root of 27, that's 3. So I'm going to write minus 3. Then I'm going to do square opposite product square using my binomial. So x squared will be my first term. Opposite is going to be the opposite of a minus is plus. Product, 3 times x is 3x, and square, negative 3 squared is 9. So that is our full factorization of negative 3x to the 6th plus 8x cubed. For number 3, we have 4x squared plus 43x plus 30. So when it comes to problems like these, I would recommend using guess and check. So there's a lot of approaches that we could use. Whenever you think of the number 4, a lot of us always think of 2 and 2, but there's also 4 and 1. So I'm going to write on the top 2 and 2 and 4 and 1. And for the number 30, whenever I think of 30, I automatically think of 5 and 6. And then there's also 3 and 10 and 2 and 15. Now you could write down 1 and 30, but chances are 1 and 30 is not going to be the numbers that we're going to be using. And that's because our goal is to get a 43. So we need to come up with some sort of combination that can get us a 43. So before I write down anything, I'm just going to analyze my numbers. So I'm going to start by working with the 2 and 2. And I know that 2 times 5 is 10, and 2 times 6 is 12, and 10 plus 12 is not 43. So that combination is not going to work. So I'll try the next one. 2 times 3 is 6, 2 times 10 is 20. 20 plus 6 is 26. That's not 43. So now I'll try the next one. 2 times 2 is 4, and 2 times 15 is 30. 4 plus 30 is 34. 34 is not equal to 43. because I've exhausted all of my products working with 2 and 2, that tells me 2 and 2 is not it. So now I'm going to try 4 and 1 and try to come up with the right combination. I know that 4 times 5 is 20, and 1 times 6 is 6. 20 plus 6 is 26. It's not 43. So that combination will not work. So I'm going to try to flip it around. 4 times 6 is 24. 1 times 5 is 5. 24 plus 5 is 29. So that is not 43, so that tells me 5 and 6 is out. So now I'm going to try my next set of numbers. 4 times 3 is 12, and 1 times 10 is 10. 12 plus 10 is equal to 22. That's not going to work, so I'm going to try a different combination. 4 times 10 is 40. 1 plus times 3 is 3, and 40 plus 3 is 43. I found what works. So what I did is I went 4 times 10 plus 1 times 3, and that's how I was able to get 43. So I'm going to work with 4x and an x, and I have 3 and 10. So I want 4 times 10, so since 4x is on the outside, 10 will be on the outside. And I want 1 times 3, so since I have the 1 on the inside, the 1x is on the inside, my 3 is going to be on the inside. And both of these are going to be a plus because both of my signs right here are plus signs. And I'm going to verify. 4 times 10 is 40, and 3 times 1 is 3, and 40 plus 3 is 43. I know that 4 times x is 4x squared, and 3 times 10 is 30, so here is my full factorization. A lot of times it won't take that long to do, but I wanted to make sure that I went about that problem in a long way just so that you can see how to factor these types of problems using guess and check, using the full guess and check method. And finally, number 4, this is a dot, it's a difference of 2 perfect squares. So I'm going to break this down into 2 parentheses, take the square root of each term, so that's going to be a 5x and a 5x. And a plus 7y and a minus 7y. So whenever we're dealing with the difference of 2 squares, we always will have a plus and a minus as a part of our parentheses, and we're just going to take the square root of each term. So hopefully you did pretty well when it comes to factoring. Please be prepared for seeing problems like these on your test. So our learning target for today is to be able to use, I want you to be able to say, I can use the change of base formula to evaluate, that means to come up with an actual value, to evaluate any logarithmic expression using a calculator, and I want you to be able to solve a real world problem. So in the past, whenever we've worked with logarithms, we have not been able to work with calculators unless something was given to us. Like in the last lesson, we worked with numbers that were actually given to us. Well, now, what happens when your base is not the number 10 or your base is not e? How do you solve a problem? How do you put it into your calculator? Well, so far, you can't. But now there exists an actual formula that allows you to evaluate logarithms when the base is not 10. What we're doing is we're going to change the base to a base that we can actually work with. So the change of base formula goes like this. Let's say you have log base c of a is equal to log base b of a. Oh, sorry. Let's say that you have log base c of a. How do you put that into your calculator? Well, you change it to log base b of a divided by log base b of c. So what log base b is it's your common log base or your natural base. So the base that you're going to use, the base will be 10 or e, your choice. So what I mean by that is this. If you have log base c of a, you can take the log of a and divide it by the log of c, and in this case the base is 10, or log base c of a is equal to the natural log of c natural log of a divided by the natural log of c. In this case, the base is e. Please note that your base, log of base, the c is always on the bottom. So the base is always on the bottom. So what I did here is this. Let's say that we have log base 5 of 150. We can put that into our calculator by changing it to two different things. We could change it to log of 150 divided by a log of 5, or we can change it to the natural log of 150 divided by the natural log of 5. Both will end up with the same exact answer. So if I were to put into my calculator the log of 150 and then divide it by the log of 5, I end up with 3.113. If I were to do the natural log of 150 divided by the natural log of 5, I still end up with the same exact answer. And what's really cool about the change of base formula is that it allows us to evaluate whereas before we weren't able to use our calculator. By using the change of base formula, we now get to use our calculator. So why would you use the change of base formula? So here's a few reasons why, or a couple reasons why. When you can't evaluate logs by hand, this is why you would use it. So when you can't evaluate logs by hand, it's nice to be able to use your calculator. Now remember that to evaluate is to come up with a number. So when you can't evaluate logs by hand, it's nice to be able to use your calculator. So an example of something that you can't calculate by hand would be, what is the actual answer of log base 5 of 32? We don't know what that is off the top of our heads. It's going to be some sort of funky decimal, so you'd have to put it into your calculator using the change of base formula. And that's another reason. We use the change of base formula so that you can actually evaluate logs using a calculator. So we would change it so that we can evaluate, or in order to evaluate logs using a calculator. Because in order for you to use a calculator, you need the base to be 10 or the letter E. Because base 10, that's where what the word log is by itself, or base E, that's what natural log means. Natural log means that the base is E. Let's go ahead and practice some of these on the next page. So on the next page, we have evaluate log base 6 of 11 using common logarithms, which common logarithms means that we're going to use just log, which in that case, that means the base is 10, and natural logs, which means that we're going to use ln, and that means that the base is e. We're going to round our answer to the nearest thousandth, so that is 3 decimal places. So please make sure that you follow instructions, especially when you take your test, that you actually pay attention to where you're supposed to round, because I'm now going to be marking off for rounding errors. So please make sure that you round appropriately. So if we're going to evaluate using common logarithms, that means that log base 6 of 11, before we couldn't put it into our calculator, now we can. Remember that it's going to be log of what you're taking the log of the base of divided by the log of your base. So the base always goes on the bottom. So I have a log of 11 divided by log of 6. And all you're going to do is put that into your calculator exactly as you see it. So I'm going to go log of 11 divided by log of 6. And by doing that, we end up with 1.338. So this is approximately 1.338. And that is it. That's all you do. Now we're going to use natural logs. So you have a choice. You can work with logs or common logs or natural logs. Most of the time, the directions will not tell you what to use. It's your choice. So it just depends on what button you want to press. But once again, we're going to take the natural log of 11 divided by the natural log of the base, which is 6. And I'm going to put that into my calculator exactly as I see it. So I'm going to write natural log of 11 divided by the natural log of 6. And voila, we end up with the exact same number of 1.338. That is it. That is all you do. So if you want to go ahead and pause the video and try example number 2 on your own, just to make sure that you know what you're doing and how to use the change of base formula to evaluate the log, that sounds good to me. Go ahead and pause the video and see if you can do it. I recommend that you use make one of them using a common log and the other one using a natural log, so you feel comfortable with either way. All right, let's see how well you did. So we have log base 16 of 26. I'm going to use common logs. So I'm going to write log of 26 divided by the log of 16, and I'm going to put that into my calculator exactly as I see it. So I have log of 26 divided by, or better close my parentheses, divided by the log of 16, and I end up with 1.175. And there's my answer. For letter B, I'm going to use natural logs just for fun. I don't have to. You can use common logs for all of it. It doesn't really matter. I just recommend that you try both. So we have log base 5 of 13. So I'm going to write the natural log of 13 divided by the natural log of 5. And I'm going to put that into my calculator. The natural log of 13, close my parentheses, divided by the natural log of 5. And end up with 1.594, so approximately 1.594, rounding it to the nearest thousandth. And there's my answer. We have one more problem and then we are done with this lesson. And it says for sound intensity, we'll call it I, in watts per square meter, excuse me. The loudness L of I of sound in decibels is given by the function L of I is equal to 10 times the log of I over I sub 0, where I sub 0 is the intensity of a barely audible sound, which is about 10 to the negative 12th power watts per square meter. So what this represents is I sub 0, and that's the number that we're going to use for I sub 0. This is something that you will need to know for your homework. So use this problem for your homework. The intensity level of an electric guitar is 10.28 watts per square meter. So the intensity level, which is your I value, so in this case 10 to the 2.8 power, that is your I. We want to find the guitar's loudness. So we want to figure out what is L. So we are given the formula L of I is equal to 10 times the log of I divided by I sub 0. We know that I is equal to 10 to the 2.8 power and I sub 0 is equal to 10 to the negative 12th power. So I'm going to substitute both of these numbers into my formula and then I'm going to simplify from there. So I'm going to write L of 10 to the 2.8 power is equal to 10 times log of 10 to the 2.8 power divided by 10 to the negative 12th power. So now once you've entered in these numbers into the formula, you want to simplify as much as you can. So what we have here is two powers with the same base, and we have our exponents. And this exponent is negative. It means it's not happy where it's located. So I'm going to bring that 10 to the negative 12th power up. So I have L of 10 to the 2.8 power is equal to 10 times log of 10 to the 2.8 power times 10 to the 12th power. So I brought that up and I'm now going to be multiplying. So I have two powers with the same base, so I'm going to add my exponents. 2.8 plus 12 is 14.8. So I have L of 10 to the 2.8 power is equal to 10 times log of 10 to the 14.8 power. Now, technically when a log is alone, the base is 10. And if you have log base of the same number, so we have log base 10 of 10, we learned a couple of lessons ago that whenever you see something like that, it cancels out and your exponent is your answer. So I'm going to write L of 10 to the 2.8 power is equal to this 10, the first 10, times the exponent, which is 14.8. This is going to happen, this log base 10 of 10 is going to happen in your homework. So you're going to have to show how you got to that point because this part is going to cancel out. You'll simply be left with this 10 on the outside times whatever your exponent becomes. And 10 times 14.8 is 148. So we have L to the 10 to the 2.8 power is equal to 148. And now because this is a problem that has context, we need to figure out what our units are. So I'm going to go back to my story problem, and it says loudness is in decibels. So this is 148 decibels. And that is it. That is your answer and the end of today's lesson. If you have any questions over anything that I talked about today, please feel free to email me. Otherwise, I hope you have a wonderful day.